All right, so our last piece when it comes to functions and introduction to functions is, well, how can we represent functions? And there are actually 4 ways that we can represent a function. So maybe there we go. So we can represent a function by ordered pairs, right? So ordered pairs. We can represent a function using a graph. We could use a table, which were all ways that we could represent a relation. The other way to represent a function, I guess you could put mappings in here, but the other way you can represent a function that we'll be working with is by a rule, or I just call it an equation. And so for all of these go together, and their equation would be that y equals 3x, because 1 times 3 is negative 3, nope, make that a negative 3x. 1 times negative 3 is negative 3, negative 3 times 2 is negative 6, right? And so we can use that equation to make a table, a graph, or ordered pairs. All right, so example 5. Which table could be a view of the function represented by the graph? So what we're needing to do is we're needing to match points. So here we have 0, 0, right? That's on this graph. And then we go 1, 3. So if we go 1, 3, oh, well, that's not on my blue line. So it can't be this first one. And then here we have 0, 0. And then 1, negative 3, that's good, and 2, negative 6. So those are matching. So this one should be, and then I'm just going to double check. If I go to negative 3 and up to 6, I'm not on the blue line, so it can't be this last one either. So you're just checking to see if the points from the table land on the blue line. That's it. Okay. Example 6. A train leaves the station at time x equals 0, traveling at a constant speed. The train travels 332 kilometers in 2.9 hours, round to the nearest 10 kilometers and to the nearest whole hour. So the first thing we're going to do is I need to round to the nearest 10 kilometers. So 332 would become 330 kilometers, and 2.9 would be 3 hours. Okay, so right now we know that we are doing 330 kilometers. Ooh, that looks pretty gnarly there. Let's try that again. 330 kilometers every 3 hours. And so then I can put that in my table. For 3 hours, I travel 330 kilometers. Now here I have to be careful, right? Oh, I can do my ordered pair as well. 3, 330. Here I have to be careful because there's only an hour difference, right? So I need to know, well, how far have I gone in 1 hour? And so to figure that out, we're going to do 330 divided by 3, which will give us 110. So we travel 110 kilometers every 3 hours, or every hour. So 110 per 1 hour. That's what this means. So I'm going to take 330 and I'm going to add 110 to it. So that would be 440. And so then my next point is going to be 4, 440. And then for 5, I add another 110, which will make this, right, 110, which will make this 550. So my other point here is 5, 550. So I filled out the table. I need to use an equation and a graph. Well, my equation is the fact that I'm going to have y equals my per hour. That's what I'm going to use, 110 and then x is going to be how many hours I travel. And we'll talk more about equations. And now I just need to graph these points. And so I'm going to do 1, 2, 3, 4, 5, 6 across the bottom. And I'm going to go by 110 up the top. So 110, 220, 330, 440, 550. And then from here, I'm just going to plot these points. I've got 3 at 330, and 4 at 440, and 5 at 550, and that would have meant that at 2 I would have gone 220, and in the first hour 110, and then we would have started at 0. And then I draw a line, and there's the graph of my function. Most of what I'm going to be asking you to do is going to be filling in a table based off a graph, but I wanted to introduce you to this as well. And then that's all that I have for you. Yep. So, see you next class.